All right, so this is a little bit meta. I've got the video I recorded of throwing a tennis ball, and I'm going to use that to show how I could use the information to write an equation. A video of something flying through the air. And so what I'm going to do is bounce the ball, and I've got the ruler right here, and we're going to try to find the highest point of the ball. So let's try that again. And I can use that. So we can use that bounce to try to figure out where the ball is. So let's try to scrub it back just a little bit. Okay. Work with me here. Looks like about 20 seconds. Try that again. So the ball hits the ground at about 21 seconds. And then at 22 seconds, it's at the height of its curve where it hits the top of the ruler. And this ruler is a little bit weird. This is a ruler that happens to be 20 inches long. You probably can't see that through the video, but this is longer than a standard 1 foot ruler. So we got 21, 22 seconds, it's on the ground, 23 seconds, it's at the top. This isn't the most accurate thing because it's probably more like 22.2 seconds and then 23.8 seconds. So if you are able to get more precise with your measurements, then you'll have a more accurate equation. But we're just going to use x equals 22 and x equals 23 as our approximations. It's good enough for what we're trying to get done here. So what I'm noticing is that the ball, I'll just draw the graph right here. The ball was on the ground at x equals 22. It went up and it hit the ruler at x equals 23. And the size of the ruler is 20 inches. Again, I have these weird rulers in my classroom. I don't know why they're 20-inch long rulers, but they are. And so I've got 22, comma 0, coming up to 23, comma 20, which was it hit the top of the ruler, and that was also the vertex. And so if the ball continued on its path, it would come down right there. You can probably predict when it's going to hit the ground just based on the symmetry. But what you can do then is use that information to write the equation. So I can write the equation like this. Y equals A times x minus 23 squared plus 20. So I use the vertex right there. And I should make sure that I clarify that in this equation, x is the number of seconds from the beginning of the video, and y is the height. So I guess I should have said x is the time measured in seconds, and y is the height measured in inches. The other piece of information I have is that the ball, I bounced it off the ground at 22 seconds. And so I can take 0 for the y value and take 22 for the x value and go 0 equals a times 22 minus 23 squared plus 20. Solve for a like we've been practicing in our class. So subtracting 20 gives me negative 20 equals a times a bunch of stuff. Work from the parentheses. So that's negative 1 squared, because 22 minus 23. Negative 1 squared is 1. Dividing by 1 gives you that negative 20 is your a value. So now I know my exact equation is negative 20 x minus 23 squared plus 20. Now I got to point out, this is obviously not perfect. The ruler wasn't straight up and down. The video, I rounded it off to the nearest second, so that's a little bit of an error. But it's actually pretty close. The real number that would happen with the force of gravity should be negative 16. We got negative 20, not that far off. just like a 25% error there. If you have a more precise video, if you have a better measurement, then you'll get a better equation. One last thing I want to point out is part of your project is finding the other two versions of the equation. You can find the factored form because you know that it's got the same A value and you know it was on the ground at 22 seconds. And based on symmetry, if it went up for 1 second, it's going down for the other second. So x minus 24. And the last thing is to find the standard form. And you can get the standard form by multiplying x times x times negative 24, negative 22 times x, and last, negative 22 times 24. That's one I don't know off the top of my head. Suppose I could get it, but 22 times 24 is 528, and all that junk is going to get multiplied by negative 20. And so we'll get y equals negative 20x squared. I'll combine those to get 46 and multiply that by 20 to get plus 920x. And then I'll do 528 times 20 to get negative 10,560. And this tells me that the y-intercept would be 10,560 inches below the ground, which is obviously not realistic. But if somehow the tennis ball could go back along that same pathway, down like this along the graph, boop, 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 if it could keep going down, it would intersect the y-axis 10,000 inches below the ground for whatever that's worth. So this is the basic idea for the project. You film a video, you find the exact equation of the object going through the air, you find all three versions of the equation, and you'll do a little write-up explaining what those different things mean and whether or not they make sense. Like the y-intercept here, I explained verbally what it means and how it doesn't really make sense because the tennis ball can't go backwards in time and it can't go through the ground. So please comment, ask questions, let me know how else I can help.